Welcome to our second lecture on fundamental of casting and solidification. In lecture 2, we are going to discuss about type of molds and casting processes based on that. So, in last class, we have discussed the 5 stages in the casting process. First is pattern making, mold making and core making, melting and casting, fettling, testing and inspection. In pattern making, what is pattern? Pattern is a replica of the product with some allowances. Okay, that we will discuss later. Okay, so what we have to do? We have to make a drawing. Based on that, we have to decide which kind of pattern we have to make. Single pattern, loose piece pattern, and a skeleton pattern. Okay, pit molding, which we have to decide on the shape, size, features. If I want to make a hollow product, that we will discuss, then we have to make cores. So, you have to design that core also. So, we will see that. Okay. Similarly, after making pattern, you have to make mold, which will be covering around the pattern, and when pattern will be removed, there will be a cavity where we will pour the molten metal, melting, you have to melt and you pour into cavity, you will allow to solidify. Okay. Then we will give a final casting product, and after that we are getting casting. Let's assume sand is the molding material. You have to break that. Okay, extra material you have to cut, that is called fettling. You have to clean the surfaces around the product, and you have to cut the extra unwanted materials, and then you have to go for machining and whatever you want, heat treatment all. Then finally you have to go for testing and inspection, and based on that there will be various all analysis, accuracy, precision calculation or statistical analysis will happen here. Six Sigma concept comes in this section. Okay, industrial engineering comes here. Okay, so core, I am discussing about core, mold and core making. In core making, you can see what is the core. Core is a sand material which is used to make hollow product. So, let us assume I want to make a hollow chamber, hollow circular area in this casting. This is the this is the pattern, this is a riser, this is also a riser, this is a gating system, pouring cup, sprue and ingots. Okay. I want to make a hollow feature in this product. So, what we can do? We can place a sand material, and that is known as a core. Okay. We will place that so that it will not solidify this area, and after the solidification the sand we can break that sand and we will get a hollow product. So, this is called core making. So, mold making and core making are one section. Okay. There will be no too much difference. Okay. Just you have to get pattern design. Based on that, you have to design your molding and core making process. If there are no hole, there is no hollow product, there is no core making. If there is a hollow product, you have to provide a core. Okay. So, these are just brief understanding. Okay. In chapter wise, we will go in details like fettling, what is fettling, why it's happened, what is casting, what is solidification. They will go in detail what is the molding and all. Okay. Now, we are starting the type of casting processes. There is based on the mold and pattern. I want to divide casting process in 3 sections. First will be expandable molds with permanent patterns. Expandable mold with permanent patterns. Second, expandable mold with expandable patterns. And third is metal or permanent mold processes. Okay. So, casting can be divided in 3 type. First will be expandable mold, means you are going to destroy, or after the casting you are not going to reuse expandable mold, but pattern is permanent, means you are not going to destroy pattern. Pattern is fixed, but you are going to change mold always. So, first category. Second category, we are going to change mold after each casting. as well as you are going to change your pattern each time. That is called expandable pattern. This is second category. Third category, where you are using metal and permanent mold processes. You are using metal and permanent mold processes. So, first you will category 1, we will go category 1, expandable mold with permanent patterns. So, what are the examples? So, examples will be, you can divide into 4 subsections: bonded, sand molding. Second will be slurry molding. Graphite rammed molding. Fourth, non-bonded sand molding. From name, it is all 4 are very clear. Bonded sand molding. Obviously, you are using sand mold you are using, but there is bonding. How can you sand can bond? By using fire clay, binder and all, and moistures. Okay, so based on that we will divide it. So what is happening? Your pattern is in this, what will you use? Wooden pattern, metallic pattern, whatever pattern you are using, you are not going to change that. Okay, you are not going to change that in after use. You are going, it is going, lifetime of pattern is very long. Okay, you are going to make 1,000 kind of product, then you maybe you can change or something, or maybe higher. But what is happening with mold? Mold, after the casting you are going to break and you are going to make again. Okay, each time you are making new pattern, sorry, each time you are making new mold. So expandable mold, but with pattern is fixed, permanent patterns. So bonded sand can be also divided as green sand. So there can be natural or synthetic. Okay, CO2 based sand casting. Okay, third can be resin base. There you cold box sand casting, hot box sand casting, and third is cell molding. Very popular cell molding, we will show that. Okay. So expandable mold, which is made of sand, first category can be bonded sand, and bonding can be happen by natural sand, sand with natural binders, synthetics, CO2, cold box method, hot box method, and cell molding, where we use sand only, but there is binder and moisture will be there, either in be natural forms or you chemical bonded form. Okay, that is the category. Slurry molding. Slurry molding can be, slurry we make plaster or ceramic. Okay, there are 2 category. Slurry molding will be plaster and ceramic, and graphite rammed molding is already one category, but non-bonded sand molding. What is happening? You are using sand molding, but there is no bonding. So how can we do? Vacuum. We can create external force to bind the sands. Okay. First category vacuum molding. Second we can be magnetic molding. Okay. These are the popular category where expandable mold with permanent patterns. Okay. Any doubt? Hoping that is clear. Now next category, category 2. Next category is expandable mold with expandable patterns. Okay. Next category is expandable mold with expandable pattern. What is happening in after each casting, you are going to break mold, as well you are going to invest your pattern also. You are going to invest money after in each pattern. Okay. So, what is happening? A very known popular technique we know. First is investment casting. Second is lost foam casting. Third is counter gravity casting. Very popular investment casting. What we do? We make pattern of wax. And what happens when we make a pattern? We up around that we make a mold also. After that, what we do? We go in the oven and we evaporate and melt the wax. So we have already invested money. Okay, they not you can't use that pattern again. Okay, so again expandable patterns, and after that, after the casting, you are going to break your mold. You are not going to reuse. So that's why it is a second category. In lost form casting, what happened? Very clearly understandable by name. We make pattern of lost form, which is made of foam. Okay. And third category will start metal or permanent mold processes. That is a huge category. Okay. It can be subdivided in two categories. High pressure die casting, pressure die casting, high pressure die casting, permanent mold casting. That can be divided, permanent mold casting can be divided in two parts, that is gravity low, and second will be low pressure mold. Okay. And high pressure die casting can be divided into, this is also known as HPDC casting. This is a very popular technique. HPDC, there will be hot chamber casting, cold chamber casting, direct or indirect squeeze casting, okay, slurry casting, Rio casting, you can say okay. These are the popular names. There are lots of categories, okay, like Rio casting, Thixo casting, direct squeeze casting, indirect squeeze casting, cold chamber die casting, hot chamber die casting. There are lots of processes are there. Okay. So based on that, high pressure die casting divided in subcategories. So there will be permanent mold with and metal mold. There will two category, permanent mold casting or high pressure die casting. Okay. There is a permanent mold casting can be divided into gravity permanent mold and low pressure permanent mold. Okay. HPDC has lots of different categories like hot chamber, cold chamber, direct squeeze casting, indirect squeeze casting, slurry rehook casting, thickso casting. Okay. So this is the third category. So their whole casting can be divided into three parts. Okay. And another category which is merger of both plus permanent. And permanent, that is called centrifugal casting. Why we kept merger? There is a metal mold, sand and okay. You can use centrifugal casting where mold can be expandable or permanent. In permanent, metallic mold obviously, which is used for make pipes, hollow pipes, and expandable mold where sand and rubber can be use your mold material. Okay. So mold making, there is a first flask or mold is there or mold without mold. Okay. In mold making, what is there? Mold is there, mold is flask is there or not. Okay. So flask, you can say very interesting two mold is there. Okay, mold 1, mold 2, bottom mold is called drag and top mold is called cope, and in between molds are called chicks. Okay. Drag is bottom mold, top is called cope, and in between molds are there, flask is used, that are called chicks. Okay. There is a, you can say there is a mold like pit mold casting. Pit mold casting, there is no flask. Okay. Pit mold casting means underground we go cast material in underground. Ladle and all are made by pit mold casting because size is very high, huge. So you can't make pattern always. Okay. And very its demands is not very popular. It's come for not frequently. Okay. So what properties should govern a mold? Mold has good strength, permeability, we will understand that, thermal stability, collapsibility, reusability. Okay. Very popular from the last section also, expandable mold with permanent patterns. There is a green sand casting, dry sand casting, skin dried or skin dry. Okay. What happen? Green sand, there is a moisture is there. Okay. In dry sand, what will happen? We will do, we will first moisture will be there, then will we go for oven where all moisture will be removed because there will be some organic binding. There will third will be skin dried near the mold area, near the pattern area. We will remove our, we will use heat and remove the moistures in that third category. Okay, that is skin dried. So mold properties, green strength when your moisture is there, in that compressive and shear strength in range of 30 to 160 kilopascal, 10 to 50 kilopascal for the green strength. Okay. Dry strength when we have heated. Why you need this dry strength? Green strength, why? First you are making mold. Before pouring, your mold should sustain. Then only you are pouring, it should not break, isn't it? Before pouring, you are handling somewhere, you should not break. Okay, mold should not break. So you need some strength. But why you need dry strength? But when you pouring the molten metal, what will happen? Material become, sand become hotter, isn't it? Because temperature of, let's assume you are using casting of aluminum, the melting point is 660 degrees Celsius. So temperature of the cavity around 700, because pouring temperature is around 700 degrees Celsius, which is higher than melting point, 40 degree superheat. So what happened? Sand become, moisture evaporates. Okay. So what happened? sands are there. If they know which is dry, now in dry in nature, if they know strength, okay, in dry position, what will happen? It will collapse, isn't it? Then you can't get a product. A product will not sound, isn't it? Defect will come, okay. Even you can't feel also. There are some chances that you can't feel the casting. That's why we need dry strength, okay. In that the strength should be higher than the green strength, okay. It should be higher. Mold hardness, hot strength, permeability. What is permeability? The permeability is defined as ability of any material, not about sand. It's a permeability for the porous media, any kind of porous media. Like your sounds and all, you can see lots of porous box are there, honeycomb structures all are there, okay, where fluid is flowing something, okay. Any porous media which is allowed to pass the gas or fluid, okay. Though it is ability, it is a one kind of ability to allow passes the fluid, okay. Permeability number, it is denoted by K. In casting, it is a non-dimensional number which denoted by VH by PAT. Permeability number is defined by VH divided by PAT. What is V? So, what we do? We make a mold sample in a cylindrical manner, okay. This is a mold material, sand mold, green sand mold, I will write green sand mold material, and prepare like this. H will be 2 inch in height, pressure will applied, okay, air pressure, permeability number K equal to permeability number, volume of air passing through the spacer. What we do? We make a, we are preparing the sand with binder, moisture and all, clay and all, and we will prepare a cylindrical sample where we will pass a gas, air will pass air. So, it is just ability to measure the how air is passing or not, how much air is passing. So, if you are going another material like fluid dynamics, there will flow, okay. Okay. So, the how much flow is happening, area, its permeability comes from the Darcy law, where K, a small k, and the dimension is meter square. It is one kind of area which is allowing to pass the gas or fluid, okay. So, something like this, and but casting we do not go about permeability, they directly calculate permeability number, that is equal to VH by PT. V is the volume of how much volume of your area gas you are passing from here, how much, what is the pressure of the air, okay. H is the height of the sample, that is 2 inch, area of the cross section area, okay. So, it is generally we are take like this standard sample, and T equal time, how much time you are allowing to pass the gas, okay. So, based on this you can put this formula and you get this. It has some number, okay. This is called permeability number, and this permeability number can be linked by Darcy law, that is permeability, similar kind of thing, okay. This is meter per second velocity equal to minus K A del P by mu L. So, based on that mold properties are something like this. You can binder and clay are fry clay, bentonite with sodium, bentonite with calcium, permeability in range 60, 110, 108. Okay, so you can see the permeability number is in 100 order, in 100 order of 100, around 100. Okay, similarly, green strength and dry strength, you can see dry strength is higher, should be higher in the this in green sand mold. Okay, and last sections, if you making a mold, so what you have training, you have sand, you have some binder like bentonite with sodium, like sodium or calcium base, fire clay, and you are adding some moisture, water, directly you are adding some water. In general, 2 to 3% range, 2.5% is ideal if you keep. Okay, so you are keeping 2 to 3%, 4%, 5%, 10%, you are adding water. What will happen with that? So, flowability, if you are adding waters in sand, so what will happen? First, flowability will decrease. You are, let's assume 100% sand, you are just adding some water. What will happen? It will not allow to flow too much. It will be slurry kind of thing. Okay. As you are adding more water, what will happen? Your fluidity will be very high. What will become? It will become jelly, isn't it? It will be very high amount of water. It will easily flow. Okay. So, for more a concentration till 4 to 5%, you will see a decrement in flowability. So, flowability should not high, okay, in our sand casting. Second is permeability. Permeability allow ability to pass the gases. Okay, it should be not less or very high also. So, if you are adding some water, what will happen? You will increase your permeability. But after some time, what will happen? You are adding more water, you will not allow to pass the gases and it will start to decrease. Okay. Strength. What will happen with the strength? If you are adding some water, so it will not, initially it will not bind, but as you are adding some more and more water binding, then what will happen? Strength will increase and it will reach maximum. More water you will add, then it will flow will be more, it look like a liquid. So, there will be low strength, decrease in strength. Similarly, if strength is decreasing, but deformation will be very high. As you add water, deformation will be very easy. Deformation will continuously increase. So, based on that, we always decide our best mechanical properties for our mold materials. And cell molding, very popular technique. We use skin dry, we use resin binder, and we can, this is the mold where we are going to, pattern is going to be fixed, but mold is expandable. Okay. Thank you.